So yesterday what we did was we took the data that we had collected with the Barbies in the classroom. The students had collected their data with the rubber bands and the Barbies, and we put that data into graph form. So they had to come up with the scale, correct scale for their axes and plot their data. And then the students developed their own line of best fits.
5 was 1.
Okay, let's go ahead and plot what that data looks like. So we have one rubber band was at 0.5.
Yesterday it was kind of a bit harder. We did a hand-drawn calculation without graphing calculators.
Today, when we brought out the graphing calculators, it becomes really exciting for them. What we're going to do is we're going to take data points, your data points, and we're going to enter them into the graphing calculator. You hear a lot of, oh wow, that's neat, oh cool, the calculator can do that. And so as they're entering their data in, it's still doing everything the same way. They put it into a table and plot the points, but the calculator makes that process very efficient for them, and so they can get immediate feedback on what the data looks like.
What I like more about Bungee Barbie than other projects is that we actually get to interact with technology, and like just with the book we only get to read and just analyze, but like in calculators you get to interact and put them in and actually do all the stuff yourself.
The next step's really cool, because what we're going to do is we're going to look at this line that the equation that the calculator just came up with. We're going to have the calculator graph this line right through our data points. Just like we drew our line of best fit, we're going to have the calculator draw its line of best fit.
We've got to learn how to work the calculators and how to compute and enter equations that normally other calculators don't do.
Today we did it with a graphing calculator and we put all our data in. The graphing calculator put what it thinks the line would be, and it would come out a little bit different, but it would pretty much be the same.
So we're going to take a look at how yours that you drew by hand compares to the calculators, and we're going to use those two equations to predict how many rubber bands you're going to use for the big jump tomorrow. Okay? So I gave them the height of the roof for tomorrow's big jump, and they use that value, they put that in for their distance now, and then they can calculate how many rubber bands am I going to use to get my Barbie to fall as close to the ground as possible and hopefully not die. You're going to have to decide, do I like what the calculator came up with? Do I like what I came up with? Or maybe they're the same, or maybe they're really close.
So the challenge of this Bungee Barbie project is that we are not trying to let Barbie die. And so we have to make a correct number of calculations. It takes this many centimeters for Barbie not to die and this many centimeters for the Barbie to die. So we're canceling those out and we're putting the right ones in.
Do I think I want to use 15, 17, 16, 18? That's the decision you need to make. Write it on your card. If you have second thoughts when you come in tomorrow, you can change what's on your card tomorrow.
So tomorrow we're going to attach 16 rubber bands to Barbie and drop her from the roof.